All right, welcome to chapter 1. A lot of this is going to be review. Specifically, this lesson will be a lot of review in lesson 1.1 for graphs and utilities. Again, a lot of review from Algebra 2, so let's just get into it. All right, let's take a look at the objectives. We're going to plot points in a coordinate system. We're going to talk about the coordinate system. We're going to graph equations, and then we're going to look at some word problems and interpret the information. All right, so a coordinate system. Coordinate system is a horizontal line and a vertical line that intersect at right angles. You've seen that before. It's a coordinate plane. The horizontal is the x, the vertical is the y. Where they intersect is the origin. Positive numbers are, well, x is positive to the right and negative to the left. Y is positive up and y is negative down. All right. When you plot ordered pairs, the x comes first, the y comes second. And that would be a point on the graph. And again, the x comes first, the y comes second. Let's plot 2 points. Negative 2, 4 would be left 2, and then up 4, so that would be right about there. B, which is 4, negative 2 would be right 4, and down 2. So that's where your B value would be. Okay. Okay. The relationship between two quantities can be expressed as an equation. So y equals 4 minus x squared is an example of an equation. The solution of an equation in two variables, x and y, is an ordered pair of real numbers with the following properties. When the x coordinate is substituted for x and the y coordinate is substituted for y, we obtain a true statement. So basically, a solution to an equation is a ordered pair that makes it a true statement. All right, let's pick an absolute value equation. So y equals absolute value of x plus 1. We're going to just graph it by plotting points. So we're going to pick x values beginning with negative 4 and ending with 2. All right, so when we plot negative 4, we plot negative 4, or substitute negative 4 into the equation. Negative 4 plus 1 is negative 3. The absolute value of that is 3, so the ordered pair would be 3. We're going to do that for, again, just substitute negative 3 in, negative 2 in, all the way down to 2. See what you get for y, and then the ordered pair is on the right there. We're going to plot those ordered pairs. So each of the ordered pairs from that table are plotted on this graph, and then we just drew the lines through it. And that is the absolute value function. If you're going to use a graphing utility, basically we're talking about a graphing calculator. You enter the equation, and then you got to specify the size of the viewing rectangle. Honestly, I typically don't worry about exactly what I'm about to describe in these notes. What I typically do is I graph an equation, and then I use zoom in, zoom out, those kind of functions in order to be able to see what I'm graphing. But this is another way to do it. Okay, so again, it's not typically what I do, but we can talk about it for sure. The size of the viewing rectangle sets maximum and minimum values for both the x-axis and the y-axis. So if this is considered the viewing rectangle, what's being described here is in the first set of numbers. Sorry, let me go back for a second. Refers to the x values. What that means is negative 10 is the x value all the way to the left. 10 is the x value all the way to the right. That third number is the scale, meaning on the graph, each tick mark represents 1 unit. And then the same thing would be for the y's there. Negative 10 would be the bottom, 10 would be the top, and each tick mark is 1 unit. That's what's considered the standard viewing rectangle. All right. On your graphing calculator, when you open up window, this is what that means. Okay. Um, well, this is another example of it. What that means is negative 100 is all the way to the left on the graph, 100 is all the way to the right on the graph, and the scale is 50, meaning each tick mark is 50. For the y, negative 100 is all the way to the left, 100 is all the way to the right, and each tick mark is 10. Okay. And then that's just described there, what I just said. All right, intercepts, the x-intercept of a graph is the x-coordinate of a point where the graph intersects the x-axis. The y-coordinate corresponding to an x-intercept is always 0. The y-intercept is basically the opposite. The y-intercept of a graph is the y-coordinate of a point where the graph intersects the y-axis. The x-coordinate corresponding to a y-intercept is always 0. So I believe on the notes that I provided with you, I think it's a line, same difference really. If we're looking at the x and y intercepts, well, the x-intercepts are here, here, and here, because it's where the graph is crossing the x-axis. It actually only crosses the y-axis one place, which would also be the origin, right? So the x-intercepts are at -2, 0, and 2. The y-intercept for this is only at 0, okay? All right, and then we're just going to look at one word problem here. Divorce rates are considerably higher for couples who marry in their teens. The equation D equals 4n plus 5 models the percentage D of marriages that end in divorce after n years if the wife is under 18 at the time of marriage. Okay. Determine the percentage of marriages ending in divorce after 15 years when the wife is under 18 at the time of marriage. So in this case, essentially what you're just being told is 15 is the value of n. Okay. So again, to determine the percentage of marriages ending in divorce after 15 years, we're going to substitute 15 in for n. So we took the function that we were given, we substituted 15 in for it, and you end up with, well, 4 times 15 is 60, plus the 5 that's in the function is 65. So what that's saying is, after 15 years, when the wife is under 18, when she got married, 65% of those marriages have been divorced by 15 years. All right, and then that's the graph. How can we check our answer to make sure it was right? Well, if after 15, so if the n value is 15, what's the value on the function? If I interpret that to the y-axis, it's about at 65. So our answer seemed reasonable. At this point, you're going to be assigned the 1.1 practice in Math Excel, and I'm certainly available to help. I'll have already explained all that probably by the time. Well, I'll probably explain that as soon as we're done watching this video in class. All right. So back to Mr. Savini in real life.